Okay, here we are investigating finding the slope of the tangent line. And so we're looking at this line right here. Now the problem with trying to find the slope of a tangent line is we only have one point. I realize, of course, in the graph it may appear as if it touches it more than once, but that only has to do with the thickness of our marker. So what we do instead is we pick some additional point on the graph and we draw a secant line. So we have this blue line coming through here now, using this additional point over here. And you can see the slope of that secant line, since we have 2 points, although it's not the same as the tangent line, it is at least close. So let us form now a second point, picking the second point now with the green line, and I can look at again the slope of that secant line. Now that line again does not have the same slope as the red line. In this case it's actually steeper, the blue line's shallower. And so what we say is, okay, well, if we get a little bit closer, maybe we'll have a better estimation. So we pick another point, this little orange point, which is a little bit closer than both my blue and my green point were, and we form a line that goes through that point and the point on my line. You see we have another line, and its slope will go, again, although it's not the same as the red line, it is close to the red line, closer to the red line slope than the blue or even the green was. Now the idea behind trying to find the tangent line is we take a couple of little notes here. The closer we get when we pick points above, like on the blue and the gold line here, orangish or gold line here, notice in this diagram anyway, they're always going to have slopes that are smaller. Whereas if we pick points to the left and draw the secant line, we're going to have slopes that are actually larger. So just a little bit of labeling. There's my tangent line. We'll call that green line, line 1, line 3, and line 2. Okay. And what we can say here is the slope of the tangent line is between the slopes of the secant lines. Okay. So it's stuck between. And in fact, the closer I get with the points from the right hand side, the closer I will get to the tangent line. They can never get any bigger. I hope you can see that visually. They'll never get any bigger as long as I pick a point on the right. Same thing, if I pick points on the left and I keep getting closer, they're never going to get smaller. So the tangent line kind of acts like a boundary. And so because you're always going to continue to get closer and closer, and that tangent line acts as a boundary, we can say that the limit of the secant lines is actually equal to the slope of the tangent lines, or really it's a tangent line. And so what we do is we pick a second point on the graph, and we're going to give that coordinates x plus h, f of x plus h, and we're looking at that secant line. And so the secant line will just be the difference of your y values, or the difference of the x values, which is simplify to f of x plus h minus f of x all over h. And now this tangent line, not tangent lines, but rather tangent line, is going to be the limit of the secant lines. So we can then finally say the slope of the tangent line is the limit as h goes to 0 of the slope of the secant lines, which is that stuff, f of x plus h minus f of x all over h. Okay, and that's the derivation of how to find the slope of the tangent line. Because this thing now, for a given function, will be some algebraic expression that we can talk about taking the limit of.